Educational Module. Machine Learning. Learning Unit. Introduction. Machine Learning Processes and Goals. Machine learning aims the development and assessment of algorithms that enable computer systems to learn by trial and error, that is, to improve with more data their performance with respect to some task without being explicitly programmed for it. The main goals are: learn generalized knowledge that can be applied to new unseen data. Don't simply memorize. Avoid overfitting and underfitting. The fundamental goal of learning is generalization, being capable of generalizing the knowledge learned from training data to unseen instances and as a result, perform accurately. Whether a model is good depends on whether it can meet the requirements of the user or not, thus its performance has to be evaluated. The process of applying a learned model to unseen data is called testing. Generally, the test data should not overlap with the training and validation data. Otherwise, the estimated performance can be over-optimistic. Here we can see the main process of machine learning. And here is the analysis of the main stages of machine learning procedures. We will explain in following the workflow of each part. Depending on the task at hand, the data come in many different forms. In natural language processing, vectors are used. Vectors can also refer to a vector of variables like the blood pressure, height, weight, and gender in a medical data set. One of the challenges in such vector is that the scales and units of different coordinates may vary widely. In computer vision, images are used. Images can be thought of as three matrices of numbers, with each one representing the values of red, green, and blue, RGB. Video data introduces the dimension of time to images. They can also be represented as matrices. Trees and graphs are often used to describe relations between collections of objects like websites, social media profiles, or gene ontologies. Compound structures are the most commonly occurring object. That is, in most situations we will have a structured mix of different data types. For instance, a collection of web pages might contain images, text, and graphs. An emotion recognition task might include video, image, and text data. First, the machine learning model is trained by taking the training data as input. Each instance in the training data has a class/label field, which corresponds to the category it is annotated as. Other than the class field, other features include age, sex, pain, pressure, and cholesterol. Then, the trained model is given a set of test data and has to classify each of the instances. The test data do not have a field that corresponds to a class/label, it is the algorithm's job to predict the class. As far as splitting the dataset into training and test data is concerned, the most common splits are 70%-30%, 90%-10%. Cross-validation splits the data into k subsets of equal size. Then the machine learning process is executed k times in a row, by selecting one subset as the test set and the remaining as the training set. This leads to k non-overlapping test data sets and k different accuracies for the model. Cross-validation ensures fairness in the testing process and reduce the probability of randomly selecting a biased/bad test set. An example of tenfold cross-validation, that splits data into 10 subsets. Overfitting occurs when a classifier/model overspecializes on the training data and models them too well. Burnham and Anderson explained that in overfitting, noise has unknowingly been extracted as if it represented the model structure. As a result, the performance on new data is negatively impacted, leading to a very high accuracy on the training set but a low one on the test set. It is a big issue in machine learning, and certain techniques like pruning have been developed to combat it.